Hey guys, how you doing? It's Mr. Chavla. I'm back again. So in the previous few videos, I went over numbers 1 through 36 in the June 2016 Common Core Algebra 2 exam. Okay. And today, in this video, I'm just going to be going over number 37, which is our nice 6-point question. And again, this is Mr. Chavla or Mr. C. That's not how it goes. I'm getting used to my new notepad and this new that I'm writing on and this new OneNote app. So, June 2016, question 37, 6 points. Here we come. So, let's go ahead. Drugs break down in the human body at different rates and therefore must be prescribed by doctors carefully to prevent complications like overdosing. The breakdown of a drug is represented by the function n of t is equal to n of 0 times e to the negative RT power, where n of t is the amount left in the body, n of 0 is the initial dosage, r is the decay rate, right? And t is the time in hours. Patient A, who I'll use green for patient A, maybe a lighter shade of green that won't, because I'm afraid of it just blocking the text. But anyway, patient A is given the function a of t, that's fine, is given 800 milligrams. So just like n0 is the initial amount, a0 is the initial amount for patient A. So patient A is given 800 milligrams of a drug with a decay rate of 0.347. And patient B, I'll use blue for B, B of t is given 400 milligrams of another drug with a decay rate of 0.231. So we know our A0 and our R for and our B0 and our R for B. So we're gonna write. So this is asking to write two functions: one for A of t, which I'll write in green, and another one for B of t, which I'll write in blue. All right. So write two functions: A of t and B of t, to represent the breakdown of the respective drug given to each patient. So A of t is equal to A0, which is simply the initial amount 800 times the common base, not the common base, the base of E, the natural base, the natural number, to the negative R, which is 0.347, putting the 0 there is optional, times T, which is the time in hours, all in one exponent. Now if I want to write the B of T function, B of T starts with 400 milligrams. Still using base E, but the rate of decay is negative point, so the rate is 0.231, so we'll rate to the negative 0.231 times t. Okay, so that's all they said to do, to write the two functions to represent basically the amount of the drug in the patient of each body and how it breaks down through time. Then it's saying to graph each function on the set of x's below. So what I'm going to do is I'm going to switch first back to my black marker, and I'm going to count how many spaces there are on the y-axis. If I count, there's 2 spaces, 4, I'm just skipping everyone, 6, 8, 10, 12, 14, 16, 18, 20. Now how much would I have to make each width so that I could fit 800? I'd probably have to make it worth at least I'd have to make it worth 20. If I make it each spot worth 40, that's how it'll be 800. Because if there's 40, then 2 spots are worth 80. All right, then this would be 160. Plus 80 more is 240. Plus 40 more is plus 80 more, sorry, is 320. Plus 80 is 400 halfway through. That means we should end at 800 up here. Plus 80 is 480, 560, 640, and if you could set the table in your calculator, it'll make it a lot easier. And 720 and 800. So 80, basically multiples of 80. 80, 160, 240, 320, 40, 480, 400, 480, 566, and so on. And of course we start at 0, and each spot is actually worth 40, but we don't have to write every single one down. I won't write it down because it's hard to fit. Okay, so now I'm going to go into the Desmos graphing calculator, and I'm just going to get a table of values for the first equation, which I'm going to just type in as y1, or rather a of x equals 800 times e to the negative 0.347x, because I don't know if it'll let me put t. Probably will, but x is going to be just fine. X, a of x, we start at 0, and we'll just go up by a scale of 1 each time, and if we just keep going, it goes to the right by 20 on the x-axis, so if we use a scale of 1 on the x-axis, we'll be fine. And we start at 800. So we use a scale of 1 on the x-axis. This graphing is like, it's a bummer. So it goes up by 1 each time, so we got 0 down here, 1, it's 2, and I'll just skip every other one. 4, 6, 8, I don't even feel like putting the hash marks. I'll put it for this one. Wow, 10, 11, 12, 14, 16, 18, and 20. And t is the time in seconds. So we're really going up by 1 each time, right? But I didn't feel like labeling every single one, and you don't have to. So now what I'm going to do is I'm actually going to go over I'm going to start plotting points. And I said I'd use red for or green rather for the, here's my handy dandy pen. I'm going to use green for a of t. And let's just get the points. So I don't need all this. Let's smush this. I'm going to take myself out for a little while, all right? Minimize me so we could see all this. And I just want to graph the points without having to go back and forth. Okay, or at least not too much. Okay, so I'm going to move this way. And I just want to graph some points. Come on. Work with me, computer. So I'm going to graph the first few points, and then I might have to go back. All right, so 0, 800 we know to be the y-intercept for a of t. So we'll graph a of t first. I know the shade of green doesn't match. Then 565. So 560 is here. 560 plus 40 is 600. Plus 40 is 640. So 565 is going to be very close to 560 right here. Right, just basically sitting on top of the 560. Then 399.659, basically you mean 400, so just sitting right under the 400 if we're using a scale of 1, right? And then we got 282.48, okay? So if we're going by a scale of 40, and we got 80, 160, 240, then plus 40 here would be 280. So 282 is going to sit just barely over the 280. I don't know if you have to graph all the points. That's what I'm used to doing. That's what I've been taught. So it's going to sit just barely above 280. Then we got 199.7, which is just basically 200. So if we got 80, 160 plus 40 here is 200. Okay. So 199.9, I'm going to sit right under 200. And let's neaten out that 200. Not like that. What's going on here? I'm trying to get the eraser tool here. Okay, so we know that's 200. Let's try again. 200. It's really hard to do this on the computer compared to with paper. But there we go. 200. It's going to drive me crazy. 240. 200. That's better. Okay, so now we got 141.1. So if we got 80 plus 40 here will be 120. 140 is halfway between 120 and 160 because 120 plus 20 is 140. So it's basically halfway. We can't get it exact. It's just barely over halfway. So I'm just going to put it halfway. They won't know the difference. All right, it's got to be somewhere between here, these two. Like there. That's fine. Okay, then we got 99.7. So 80, that's basically 100. So when x is 6, 100 is halfway between 80 and 120. 99.7 is really close to 100. So let's just say it was 100, because we can't tell the difference with this scale. So we got 100. All right, somewhere like that. And then we got 7 is at 70, so just sitting right under 80, a little bit under 80. Then we got 49.8, which is basically 50. So if we got, each time we're going up by 40, 50 is going to be just barely over 40. Like I'm not a big fan of like having to graph this kind of stuff. And then we go down to 35.2, which is again just under the 40. All right, and then 24.9, 20 is halfway, so it'll be just leveling out at this point. And let's just see what we get when it's 11, 18, and basically you see it's going to start to level out. Then we get 12. So basically at this point it starts to level out. So I'm going to connect the graph carefully, knowing that it can't be perfect. Let me pause for a second. And look, I didn't even need to use the whole screen. Uh-oh. Okay, so let's try that again. Right here. And basically it starts leveling out close to the x-axis. And we put our arrow. I'm going to write the equation for a of t equals 800. It's always good to write the equation for the graphs, especially when you're graphing more than one equation on the same set of axes. You'll lose points if you don't label at least one of them. I'd say it's a good idea to label both. I think if you just wrote a of t, you probably would have been fine. But, or y equals a of t. Okay, I just messed that up. That's fine. Okay. Next one, b of t. So I'm gonna change the function now for the other one. B of x is equal to 400 e to the negative 0.231 t. Now we got the same values, but for b of x instead. So let's go ahead and get these points in. Hopefully this will be a little easier than the a of x graph. So I'll get the first 7, and then we'll see where we go from there. So we said we'd use blue for b. I need to find my marker because I just misplaced it as I was moving around, fidgeting. Okay, blue for b. So starting at 400, it starts with half the amount, but it decays at a slower rate. So 317 is just barely under 320, so it'll sit under here, if points could sit, right? Now we got 252, which is going to be closer to 240. Just be like sitting a little bit, hovering up there. Points can hover, float, sit. Come on, what am I doing? Then we got 200.02, just barely over 200. It's really going to sit above this point, right above 200. Okay, then we got 159, which is going to sit right under 160. I don't know why they do this. Like, these points are so, like, weird. Then we got 126, which is going to be just barely over 120. And we got 100.09, which is basically kind of, they're kind of going to intersect somewhere here. I'm going to connect the points that we got so far, because I could tell that somewhere between like t equals 5, 6, the two graphs intersect. But since the blue graph b of t is decaying at a slower rate, it's going to eventually, after t equals 6, it's going to be above the graph for the green one. And if we check, when t equals 7, we get 79.4, which is sitting right under 80. They are so close. All right. Oh, I didn't like the way that came out. Let's try that again. So t equals 7, and it's just barely under 80, like 79.4. I want to make sure it goes underneath, and these graphs like really seem to be overlapping. I can't even tell where they intersect. Let's continue the next part of, so we get so from 8 onwards, so 63, 50, so 63 is going to be a little over halfway between 40 and 80, which is 60. So let me up here, basically we just need to sit above the green graph. Then we get 50. Like if I knew if we could stop at a certain point and just put the arrows, I would do it, trust me, but I'm not sure. 39.7, so we get a little bit under 40, so we're nearing the end of this graph cycle. All right, and then we got 31 when it's 11. I'll skip that. 12 is 25, and then 13, we're about halfway, a little under halfway, and then 14, and we start leveling out from there. So it starts to level out. 15 is at 12, and by the time we're 16, 17, we're like really low. So it's just gonna go like this. That's fine. Can't have a perfect graph with these guys. Okay, so we'll write the equation for b of t, which is equal to 400. I honestly think if you wrote a of t and b of t, you would have been fine. Times e to the negative what? I don't remember. 0.231 t. It would be useful to put the decimal there, wouldn't it? I'll just put the 0 for this one. 0.231 t. And that's it. That's our graph, guys. That was a pain of epic proportions. So write the two functions, graph the two functions. Now we're gonna go on to the next part of this question. Yeah, graphing these exponents was no joke, at least not for me. To the nearest hour t, that's going to be rounded to the nearest whole number. When does the amount of given drug remaining in patient B begin to exceed the amount remaining in patient A? So they want to know when's the first time to the nearest whole number when B of t is greater than A of t. And there's not really much work we need to do here, except for we'll look at the graph and estimate. They seem to intersect at around, not at 5, but around 6-ish. So my guess is 6 based on the graph. Let's get a table for both functions, and let's see if we could get the. All right, so let's put a of x back here, which was, what was a of x? Negative 0.347. All right, and then we had b of x started at, so this started at 800, b of x started at 400 times e to the negative 0.231, was it? Yep. Okay, and then I'll have b of x in this column. That way I could see what happens. So as we could see, a of x starts off double what b of x is. After 1 hour, 2 hours, 3, 4 hours, a of x is still higher. The graph would match that. 5 hours, a of x is still higher. After 6 hours, b of x got higher for the first time. And if you want to be sure that, like, if I put let's say 5.1, 5.2, you see that a of x is still higher than b of x. 5.4, let's skip one, a of x is still higher. 5.5, a of x is still higher. So 5.5, guys, rounds to 6. So it's not going to round down to 5 because at 5.4, a of x is still higher. 5.5, a of x is still higher. But by the time we got to 6 hours, b of x was higher by that point. So it's somewhere between 5.5 and 6.0. So it has to round to 6. And at 5.9, guys, a of x is still higher. So it's between 5.9 and 6 when a of x, when b of x is higher than a of x for the first time. So it has to be 6 hours. We didn't have to show any work. Basically, the graph says it all. It's 6 hours. So we're going to say about after approximately. I should have just looked at the graph. The graph said it all. We didn't have to go through all that detail. Even looking at a scale of 1, they were so close, and b had just become greater than a. So after approximately 6 hours. That's all there was to it, guys. I overthought it, but hey, could never be too careful. It's a 6-point question, right? And assuming you'd be done with the other parts, but it's clearly 6, and the graph says it all, like I was saying, right? We should have just trusted the graph. Now, the doctor will allow patient A to take another 800 milligram dose. Let me actually pull myself back up. Let me sit up here. I've been slouching. The doctor will allow patient A to take another 800 milligram dose of the drug once only 15% of the original dose is left in the body. Then he'll take another 800 milligram dose. Determine to the nearest tenth of an hour, t, that's 1 decimal place, how long patient A will have to wait to take another 800 milligram dose of the drug. We know that's going to happen once there's 15% left, right? So patient A, if we remember the function, 800e to the negative 0.347t. We don't even need the parentheses. I'm not putting it there anymore. It's like extra work for nothing. I don't know why they put it there. Is equal to 15% of 800, because that's the initial amount. So when 15% of the original dose, which is 800, A0, is left. So 800 times 0.15. If you put that in the calculator, you're going to get 120. So we get 800 times e to the negative 0.347t is equal to 0.15 times 800. That's I get 15% of 800 is equal to 120. Divide both sides by 800, and you're just going to get 0.15 again. Now, in order to undo raising e to a power, we take what's called the natural log. So if I take the natural log on both sides, the e will cancel out, and I'm going to get just the exponent, negative 0.347t, is equal to natural log, which is just a log base e, of 0.15. Then t is equal to the natural log of 0.15, or 0.15, however you want to put it, divided by negative 0.347. Now all we have to do is find out what this value is, round it to the nearest tenth, and we'll be good to go. So I'll go to the decimal scientific calculator, clear all this stuff out. Function, natural log of 0.15 all over negative 0.347, negative 0.347, yes, is 5.47, about 5.5 hours to the nearest tenth. So this is equal to 5.5 hours. And a quick way to make sure we got the correct answer, guys, we got 5.467. I'm going to copy this. I'm going to put it in here. And we're only talking about function a, right? So I'm not going to worry about b of x. Remember, it's decaying. And we got 5.4 there, 5.5. You could see between 5.4 and 5.5, it's somewhere between 5.5 and 5.5. We get to 120. So if I copy this, which didn't let me do, 5.4672. Let's just put that part. And we see it's basically 120. And the more of these decimal places, then 0.4567 Why does it go in that order? It's 120. All right, so we know we got our answer. Is 5.5 hours to the nearest tenth. All right, so guys, that was number 37. I was gonna say let me come and say goodbye, but I realized I didn't minimize the window at this point. So make sure you got everything down, okay? So that was it, guys. That was the June 2016 exam, Common Core Algebra 2. Best of luck. Let me turn that phone off. How dare they interrupt us? Best of luck, guys. Make sure you study. Do the best you can. I'm here for you. If you have any questions, ask in the comment section. If you have any comments, feedback for me, anything you want me to know, any like new ways of solving a problem, I'm always like interested in hearing your thoughts. And do the best you can. Don't stress, okay? There's all kinds of resources around you. You got your teachers, you got your friends, you got me. All right, and I'm on your side. You got a lot of people on your side. All right, do the best you can, and make sure to get a good night's rest the day before the exam. All right, good luck, guys. See you next time.